You think drinking water is simple. You lift the glass, you swallow, you move on. But in less than 10 seconds, before that water even reaches your stomach, your brain already knows it's coming. And it reacts immediately. Not politely, not slowly, instantly. The moment water touches your tongue, receptors inside your mouth wake up. They detect temperature, texture, and even subtle chemical properties. These receptors send rapid electrical signals through cranial nerves straight to your brainstem. You are not just tasting water. You are announcing its arrival. Your brain hates uncertainty. It constantly predicts what will happen next. So when those mouth receptors fire, your brain runs a quick simulation. Hydration incoming. That prediction alone begins changing your internal chemistry. Heart rate adjusts slightly. Blood vessels prepare. Hormones shift direction. And here's the strange part. This happens before your body absorbs a single drop. Inside your brain sits a region called the hypothalamus. Think of it as your hydration control center. It monitors your blood like a security guard checking badges. If your blood becomes slightly too concentrated, meaning you are even a little dehydrated, it triggers thirst. That uncomfortable dryness, that is a carefully engineered alarm system. But when you start drinking, the hypothalamus does something brilliant. It does not wait for the water to enter your bloodstream. It uses signals from your mouth and throat as a preview. It estimates how much water is coming and temporarily reduces the thirst signal. Why? Because if it waited for absorption, you would overshoot. You would keep drinking long after your body had enough. Your brain prefers prediction over delay. Now the water travels down your esophagus in a smooth, muscular wave called peristalsis. It reaches your stomach in seconds. Contrary to popular belief, your stomach does not immediately absorb most of it. Instead, water quickly passes into your small intestine, where absorption truly accelerates. The lining of your small intestine is covered in tiny finger-like projections called villi. These increase surface area dramatically. Water molecules move across this lining into nearby blood vessels through osmosis, flowing from areas of higher concentration to lower concentration. It sounds technical, but it is simple. Water moves where it is needed. Within minutes, your blood volume begins to increase slightly. This change matters. Your heart does not need to pump as aggressively when blood volume is balanced. Circulation becomes more efficient. Oxygen delivery improves. Cells receive nutrients more smoothly. Meanwhile, your kidneys are paying close attention. Your kidneys filter your blood constantly, about 50 gallons per day. When you are dehydrated, they conserve water aggressively, producing darker, more concentrated urine. When you drink water, sensors detect the shift in blood concentration. Hormones like vasopressin decrease. Your kidneys relax their conservation mode. This is why urine becomes lighter after proper hydration. It is not random. It is a calculated response. But water's influence goes further. Every cell in your body depends on water to maintain shape and pressure. Cells are like tiny water balloons. When you are dehydrated, they shrink slightly. When hydration improves, they regain volume. That subtle expansion improves cellular efficiency, including how enzymes function and how nutrients move in and out. Even your brain cells benefit immediately. Your brain is about 75% water. Mild dehydration can affect focus, mood, and reaction time. Studies show that even a 1 to 2% drop in hydration can impair cognitive performance. When you drink water, you are not just quenching thirst. You are restoring electrical stability. And here is something most people never consider. The act of drinking itself activates reward circuits. When your brain predicts that a need will be satisfied, dopamine rises slightly. Not a dramatic spike, but enough to reinforce the behavior. That small sense of relief after drinking, it is neurological approval. But can you drink water wrong? Yes, not dramatically wrong, but inefficiently. If you chug large amounts extremely fast, your body cannot instantly use it all. Blood sodium concentration can dilute slightly. In extreme cases, this can lead to hyponatremia, a dangerous imbalance. This is rare, but it proves an important principle. Balance matters more than speed. Your body prefers steady intake. Small, consistent amounts allow smoother absorption, stable blood chemistry, and less strain on your kidneys. Evolution designed your system for rivers and streams, not gallon challenges. Temperature also changes the experience. Cold water activates more oral receptors, increasing alertness briefly. Warm water moves through the stomach slightly faster. Neither is magic. Both are variations your body handles elegantly. So what actually happens in the first 10 seconds? Signals fire, predictions form, hormones begin adjusting, thirst reduces before hydration completes. Your brain runs ahead of your body like a strategist preparing the field before troops arrive. Drinking water is not passive. It is a coordinated biological event. And here is the final twist. Most people wait until they feel thirsty to drink. But thirst is not the beginning of dehydration. It is the warning light. By the time you feel it clearly, your body has already adjusted internally to compensate. So the real optimization is simple. Do not wait for discomfort. Maintain rhythm. Let your brain operate in prediction mode instead of emergency mode. Because the most fascinating part is not that water keeps you alive. It is that your body anticipates survival before survival is fully delivered. In less than 10 seconds, without drama, without noise, an invisible system activates to protect you. And that is happening every time you lift a glass.